been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Geometry 11.1. We're going to be looking at area of triangles and parallelograms. Remember when we studied parallelograms, there's lots of things that can be considered a parallelogram. A rectangle is a parallelogram, square is a parallelogram. All right, so the formula for area of a rectangle is base times height. So the base would be that, and the height would be this. Okay, remember rectangles have 4 90-degree angles, and so the height is the distance between the two bases. It actually doesn't matter which one you call the base and which one you call the height, because again, you're just multiplying. So it's the same no matter which one you multiply first. Multiplication is commutative, so it doesn't matter. So if I say the base is 12 and the height is 5, then my area is going to be 12 times 5, which is 60. Remember that area is units squared, so whatever your unit is, you want to make sure your area is units squared. And you should be able to, given the area, solve for a base or a height using basic algebra. Square is even easier. It's really the same as a rectangle, but because all the sides are congruent, it actually can just be considered as s squared. Again, which is going to be the same as length times width or base times height, but again, they're all the same, so it's just easier to say s squared. So if s equals 8, then the area of the square is 8 squared, which is 64 units squared. If you know the area of a square, then to find the side length, all you have to do is take the square root. And the side lengths on a square don't have to be whole numbers. So, you know, if the area of a square is 50, then the side is going to be square root of 50, which is the same as 5 square root of 2. All right, so for a parallelogram, it is also base times height, but we need to make sure we understand what that means. So the base, okay, is this side, okay, these would be your bases, and your height is going to be the distance between the two bases, but it has to be a perpendicular line. So this side of the parallelogram is not my height because it is not perpendicular. So if you think about it, if I were to take this triangle, this right triangle, and move it over here, it would fit right here, which as you can see, would then make a rectangle right here. Okay, that may be a little confusing, and I can show you more about what I mean by that in class. But so that's why we have to use the perpendicular line, because this would actually be the height if it were a rectangle. So base times height, again, that height has to be at a right angle. So let me draw another one for us here, and let's look at what this would look like. So if the base is 8 inches, and then I know the height, again, that's got to be at a right angle, is 7 inches, then my area is 8 times 7, which is 56 inches squared. Remember that in a parallelogram, the opposite sides are congruent, and you also may even need to apply properties of the angles. So remember, the opposite angles are also congruent, and the consecutive angles are supplementary. So all of those rules still apply and may come into play as you're solving these problems. Our last area formula is a triangle, which is 1/2 base times height, or base times height divided by 2. That's the same thing. So again, when we talk about our height here, we're talking about at a right angle to the base. So my base would be this down here, and my height, again, is at a right angle to the base, perpendicular to the base. And it's really just as simple as multiplying those and dividing by 2, which is the same as multiplying by 1/2. In a right triangle, this is really simple because, again, if this is a right angle, then that side of your triangle is the height. And so you're just multiplying base times height divided by 2, and it's already there for you. Just be careful, again, not to use this side as your height. It has to be perpendicular, just like in the parallelogram. Okay, so if two polygons are congruent, then they have the same area. Probably seems pretty obvious. The last thing we need to look at is the what are called composite figures, okay, which are figures that are made up of multiple different shapes and aren't a special type of shape. So the area of a region is the sum of the areas of its non-overlapping parts. So for example, I have a triangle here. So I can find the area of that triangle, and then I have a rectangle. So if I find the area of the triangle and the area of the rectangle and add them up, I will find the area of the front of what looks like a house. And that works because they don't overlap. So you have to make sure you don't count a certain area twice. So the area of this rectangle looks pretty straightforward. That looks like 26 times 18, which is 468 feet squared. Now I need to find the area of the triangle. Notice it's a right triangle, and notice it's an isosceles right triangle. And if this down here is 26, then this is also 26. So I can actually redraw this right triangle with the hypotenuse is 26, and these are congruent. So normally I would call that A and I would call that B. But because they're congruent, I can call this A. And now I can use my formula, Pythagorean theorem, A squared plus A squared equals 26 squared. And A squared plus A squared is 2A squared equals 26 squared. 26 squared is 676. Divide that by 2 is 338. So A squared is 338. So then A is going to be the square root of 338, which is about 18.38. And we can simplify square root of 338. So let's see if any perfect squares go into 338. 338 divided by 16. No, 338 divided by 36. 338 divided by 49. Okay, I can't find a perfect square. Maybe it does, but let's just leave it at this. So that's the area of the triangle, 18.36. So then all I would need to do is add the triangle plus the rectangle, and that would give me the area of the entire figure, which again looks like the front of a house. So 486.36 feet squared. So you use what you know about basic shapes, triangles, parallelograms, rectangles, whatever they give you, and you can then split a figure that is combining a lot of things into different shapes and find areas of each part and add them up. Again, just making sure you're not doubling up on anything.
I've been waiting way too long. Yeah.